So it's really good to see you today. My name is Dag Brattli, working as a developer at Cognite. And today I'm going to talk about a project I've been working on for quite some time. So this is my sort of 5 to 9 project. And this talk is about from Fsharp to Python with Fable. So we are going to look into all of these 3 components to see what they are. So a little bit about myself. So I consider myself a Python programmer in love with Fsharp. And I've sort of, as you can see from the languages I've been working on, I started quite early with Python. Python 1.5, I think, or before that. And I've sort of tried to get rid of it. And even in my latest job, it took a year before I told anyone that I knew Python, because I didn't want to I didn't want to work on a Python project. But I always come back to Python. And the reason why we will look into this, but there's many good reasons for still using Python. So yeah, I'm working at the domain expert group, which so we are sort of making data science solutions for the industry. Previously at Microsoft, live in Tromsø, up far north, like 2,000 kilometers or almost. And yeah, you can see that I've been doing quite a bit of stuff. So let's look at Fsharp. And there have been quite a few talks about Fsharp already. And so we know it's a functional first programming language for .NET, maybe. And it's statically typed. But the cool thing is that it has this dynamic feel. So it almost feels like Python. But the difference is sort of that this is super robust, mature, and fast. And we have really great tooling in JetBrains, VS Code with the inode plugin, and Visual Studio. So what I'm saying is that Fsharp with its superior type system and type inference, combined with pipelining, pattern matching, computational expressions, makes Fsharp a better Python. So today we are going to see how we can use Fsharp in collaboration with Python to sort of get the best of both worlds. So let's look into Fable. What is Fable? And Fable is a compiler that brings Fsharp into the JavaScript ecosystem, which means that it basically just translates Fsharp source code into JavaScript source code. And it was created by Alfonso and Cave and many other collaborators. And it has this Fable core, which is a subset of the BCL. So it gives you a subset of .NET. So it feels like .NET. And it has Fable-compatible NuGet packages. So you can install NuGet packages that gets translated into JavaScript. So that means that you can develop like you are used to develop in .NET, but you suddenly have this magic of being able to write front-end applications. So we have been working on Fable version 4 for quite some time now. Actually several years, I think. And the new thing in Fable is not that we are sort of getting more features for JavaScript. Almost none, actually. But we are sort of scaling out this time and targeting new languages and runtimes. So the goal is to have Fsharp as the sort of ultimate DSL or specific language that you can translate into any other kind of language that you're working on. And this interaction with all these other ecosystems and communities is beneficial for Fsharp as a language and for the developers. At least that is what we think and hope. So Fable is the bridge for Fsharp developers to explore other worlds beyond .NET, which is, we are at sort of a .NET conference, but you will still see that this still feels like .NET, even if it's not. So let's look at what we have done. We have actually, in addition to JavaScript, we have added a target for Python, for Rust, Dart, and we also have TypeScript, which was already there. And the thing now is that we will soon release the new version of Fable, which is Fable version 4. And then JavaScript will be the stable component in Fable 4. Python will be in beta status, which means that we think it solves most problems. There will still be some, we don't have as much of the BCL we don't have as much as .NET as JavaScript has, but we have sort of enough. And we will add more as we go along. Rust, Dart will be in alpha stage. TypeScript is still experimental. And you can see the sort of the status between the languages, that for JavaScript you have almost 2,500 unit tests running. For Python we have passed 1,500 unit tests. So we are still a bit behind, but we are sort of moving fast towards JavaScript, even if JavaScript will sort of, every time I add 100 new unit tests, and I see Alfonso has added 200 more to JavaScript. So it's a moving target. And even Rust and Dart is sort of getting into critical mass with unit tests. So that means that every commit to Fable is compiled to all these languages. And we are running tests. So for Python, we are running PyTest. So we're first compiling everything as .NET. We are running the test using XUnit. And then we are recompiling all the code to Python. And we're running all the tests again using PyTest. And then see that we have the same result. So how does it work? So I said earlier that Fsharp takes the Fable takes the Fsharp source code and translates it into JavaScript source code. And the way we do it is we take the Fsharp source, we compile it into the Fsharp AST, which is an abstract syntax tree, which is just a data structure. It's the same thing you do with JSON. When you parse JSON, you get this data structure that represents the JSON you have parsed. So that is an AST. So we get a data structure that represents the Fsharp program. That AST is a bit difficult to work with because it's only expressions. And we know with like Python, there's almost no expressions. So we translate that AST into the Fable AST, which makes it easier for us to do stuff in the languages we want to work on. And we can do all the transformations in the Fable AST that is common for all the targets. Then we take the Fable AST and have a transformation step into like the Python AST. So this is the data structure that represents the Python program. And the final step is just a printer that goes through the AST, and if it sees a function def, it writes def. So it's basically as simple as that. So let's This is a .NET conference, so many of you might not know about Python. So let's talk a bit about Python. So for me, Python, the takeaway of Python is that it's really easy to use, at least in the beginning. And it is the most popular programming language in the world. And it's getting more popular every month. So the popularity of it is increasing quite rapidly. And this low friction of using Python makes it a popular choice for new developers. And it's also sort of the de facto language for data science. So at a .NET conference, we would say that, oh, you can do all of this stuff in ML.NET but the reality is that every sort of the cool stuff happens in Python. And if you go to a data science conference, you probably have to show all your stuff in Python, or no one will know what you're doing. So Python is the second greatest programming language for everything. So at least this is something we can agree on. If you are a C# developer, F# developer, Clojure, then Python is still the second greatest programming language for doing absolutely everything. So why would you not use Python? As I said, Python is slow. It's sort of like 10 times slower than .NET, which means that you have to spin up 10 pods instead of 1. So, yeah. But in reality, this is usually not a problem. You can still use Python for stuff where performance do not matter, or if you interface with some libraries like NumPy that is super optimized and runs in compiled C. So Python is usually more like this language to bind together all the stuff you have. But this Python is a dynamic language, and so you don't have strict typing as you have in C# or F#. You don't have this static type checker. And this makes refactoring really hard. So if you start with a small Python program, you get this huge application, or you inherit a huge application, and you suddenly need to refactor it. Then you have a really, really hard problem. Because you sort of have to put thousands of unit tests on this to make sure that everything works. There's nothing for free. So if you change a few code lines, something else over there will fail. And you have no clue why. And in Python, they have introduced type hints. And you can use static type checkers as part of the developer IDE. So you can use Mypy or Pyright, which are quite good type checkers. But the problem with them is that you can have your Python program, and it passes all the type checks you have. So the Pylance will say, this is totally fine program. Then you open the project after 1 month. Then they have fixed quite a few issues in Pylance during that time. And when you open your program, it's suddenly filled with bugs. You could sort of pin to, I say that I want to use Pyright 119 or something, and never use anything else, but VS Code will automatically update. So even if it passes in CI, you will see in your editor that this code is suddenly really ugly. And this is a never-ending story. So it is not getting better. It happens all the time, and it happened for the last 5 years. So you basically spend all your time fixing type issues. And I have several of these projects where I have to go in like every month, update the type checker, rerun it, and then I spend all weekend fixing type bugs. And it never stops. In F#, you can make an F# project, You can stash it for 1 year, you open it, and it's still the same code. It works. There's suddenly no error in it. It is the same code, and it compiles, and so this is a problem we don't have in Fsharp. So with all these problems, why would you still want to use Python? And the simple thing is really that dependencies. You have some dependency you need to use. At work, we have the IndiaCell library, the Industrial Data Science library. It's written in Python, and it's huge. And there's no way you could re-implement that in any other language. It's impossible. So we have to use it, and we have to use Python. We could have other parts of, we have other microservices running in .NET, but all the stuff that deals with this data science needs to use Python. And it could also be that you wanted to share your code. Maybe you have written some library that you want to share with other people, like this gene sequencing, DNA sequencing, or what is yesterday we saw. And all your friends use Python, then it would be cool if you could translate all your Fsharp code and publish it as a Python library. So that's why I started with Fable for Python. I still want to be part of the Python ecosystem. I have to be, but I still want to use the tools and the tooling that I love and trust. So Fable Python translates the Fable AST into Python AST. It produces currently Python 3.9 compliant code. I really want to go to 3.10 because then I get these really nice match statements. It's not an expression, but it's really good. Code confirms to PEP8, which means that if you write functions that are camel-cased, the Python code will be snake-cased. And it will produce type hints for you. So I think it's really close now that I have problems seeing a person that could write better Python code than this transpiler produces, in certain cases at least. Sometimes it generates a bit too much code maybe, but and we have async and task. And for async, it transpiles to the same sort of async that you have in Fsharp. For task support, then I sort of flip to the Python world, and the code becomes Python async await, because Python also have async await. So you can sort of choose if you want to be in the sort of normal Fsharp way of doing async with sort of implicit cancellation, or if you want to write your code so it's compatible with Python. So if you want to share this async code with Python, it will sort of have to be using task. So there's been quite a few challenges on this project. As I said, Python is sort of a statement-based. It has quite a few expressions, but it's mostly statements. You write while something or for something, or everything is a statement. But in Fsharp, everything is an expression that has to return something. You also have in Fsharp, it's quite tempting to use arrays in your code. But in Python, you don't have arrays. Or you have arrays, but no one uses them. So you have the array.array module, which no one uses. Everyone uses a list. So if you have an array of t, what should you do with it? Should you just make a list out of it? But then suddenly someone makes an array of uint8 because they want to make something they want to put on the network, then you cannot use a list. You don't want to have a list of bytes. So you need arrays. So this is, for Python, I sort of decided that everything becomes array.array, even if you sort of don't want it, but we need to make it into something. And then if you make an array of uint8, then you get a Python byte array, which is not a Python array. It's a different thing. But a Python byte array is compatible with bytes, which is what all these network libraries use. But suddenly you make an array of your class. And that's not possible to do in Python. So then I have to translate that into a list. And then it gets really complicated when you have an array of something and you translate it into, you do an array.map into something else. And if you're then flipping between generic types and other stuff, then it becomes really complicated. And Python has no other these discriminated unions or algebraic data types. There's no multi-line lambda. And lambdas cannot be type hinted either. Which is why in the code I try to stay away from lambdas, because there's sort of no good reason to use them. They are not faster. They only give you problems. So yeah, why I'm doing this, I sort of want to lower the friction of using Fsharp. I think the Python community has a lot to learn us about friction. And it would be nice to use Fsharp in Jupyter notebooks. And I know about .NET Interactive, but I don't want a .NET kernel. I want a Python kernel, because I want to use all the cool Python stuff. So I want to leverage the Python ecosystem, Pandas, stuff like that. And perhaps I would like to run safestack, which I've heard about in several other talks, this full stack application you can have in Fsharp, where you write both the front end and the back end as Fsharp code. But most of all, I think this project is quite fun to work with. And I just have to say that I didn't select this project. The project selected me. So I came into the Fsharp world, I learned about Fable and all of this stuff, and I had this huge prehistory of Python experience, and I thought I have to use it for something. So if someone was going to do it, it had to be me. So we can try to see how do you use Fable. So we can do this. Let's see. Oh, this is small. Let's find another. We can do it here. Is that big enough or? So .NET or Fable is distributed as a .NET tool. So to install it, we say .NET tool install, and we can install it globally by saying -G. And then since Python is still in this Theta release, it's not in alpha, it's not in beta, but it's in Theta. and the reason for that is that all the previous sort of experimental phase we had, then we had this Snake Island branch. So we made these Snake Island releases. And you cannot make a beta after Snake, because then you will still pick the snake when you install. So you need a letter after S. So this is how we install it. So you see we got the release 4, Theta 10. And then we can we could run it saying cd to src pi. Now we can run Fable. We give say Fable, set the language to Python, and then we can run it.
How many languages supported for Fable?
Oh, it's JavaScript, Python, Rust, Dart, PHP, and TypeScript. And PHP is still experimental, and TypeScript is also experimental, so you will not get the same kind of experience with that. Open this project. Let me see, we are in... Oh, what happened? Let's expand this like that. So, let's do something simpler first. Print fn. And Copilot said, hello from Fable. And let's say what... then we need to start, we can start, as I will show in this, that you can run Fable now with .NET Fable -lang, but you can also do this watch. So you can run it in the background. So every time you change something, you like that. And now something happened here, and we see that we have Python output. Let's remove this line here. So we can make a function, and what should we? Yeah, that sounds good. And we have transpiled it to Python. So you immediately see something, sort of one of the sort of strange or problems I have. What do I do with this unit? In Fsharp, you have a unit type, and it is a value, but it's sort of nothing. So I'm saying that you see this test is a function from unit to unit, so it has to take something, but still it's nothing. And when I want to call that function, let's see, I want to call test, and then I give it a unit as input, but we know in Fsharp that it's not like a function call with parentheses. Test is the name of the function, and we are giving it the unit value. So we want to call it without arguments in Python, but unit is still a value. So I have to sort of guard for this and say that this function might get this sort of strange nothing value. So I say that it takes nothing, but we could accept a literal none which has the value none. So you can call it without none or with none. Yeah. But we could say that we take x as an argument here. Oh, let's see, like that. And now so it infers it to be an integer. So I don't have to say that this is an integer, but in Python it has to be an integer. Or I could say that I don't know what this x is. It is probably something. And then you suddenly get this type var. So now you have generic typing in Python. So we have sort of done this. We could try to say that we have this, let me see, we saw this talk yesterday about James Dixon, bioinformatics. Yeah, we can try to steal this code. Let's see what happens. Yeah. So now we have, and if we save it, then the black formatter will go through it and clean it up for us, hopefully. Yeah, like that. Yeah, there's something I couldn't resolve, but so that would have to be. Yeah. So you can see that you automatically get all these Fable library imports, which are sort of the Python version of the BCL. So we have to refer to that library every time we need to do stuff. Let's see. Yeah, continuations. So I'm sort of obsessed with continuations. So one of the first things I tried to do was see, could I sort of write some strange code like this and say, let's see. Remove this. So could we write something that computes Pythagoras as a continuation? And we see that it produces the result. So we had a function add, square, square root, Pythagoras. And instead of returning the value, we put in a function, a higher order function, and say, give the result to this function instead. And then stuff becomes super complicated quite quickly, because you have to compute a and b, and to get a and b, you have to square a and b, but before you can square b, you have to square a, and then you give it a function that takes the result, which is the square, and then you can give it to a function that takes a b and produces the square of b, and now you can call a function add that can square, that can add the square of a and b together, and then you can give that one a function that takes the result and takes the square root of that. So now you see that we have this super complicated sort of pyramid of doom. And now the real problem in Python is that if I say let double state equals null here, so then in Python this becomes sort of just a simple thing. But if I now say state, give it the value 1, then I get this huge problem that in Python I have to declare this as a non-local. So in each of these scopes, I need to know if all the variables are being declared in this scope. Are they a global function? Are they sort of declared somewhere else? So I know how to deal with all this stuff. So that's sort of been challenges in this code. But the reason I did this is that I'm sort of obsessed with this Timeflies demo, because I implemented the RX library for Python a long time ago. So I wanted to make a demo in Fsharp that did the same kind of demo. So we have reactive extensions, observable, but I made this async RX that is inspired by async observable that was made by Bart Smet some time ago. And I don't know if you see that small, we can look at the source to see how it works. So if we go to, let's go here and we can go to Timeflies, have this library here. We can open the code for that one. And if we look at this is a program. So now I've made bindings for the TK inter, so I can do graphical stuff. I have this transformation of this stream of, I make a stream of characters, and then I do a flat map and switch each character stream into a stream of mouse moves. And then I delay each stream of mouse moves by the index of that character. And then I map it to some coordinates that I can render on screen. So for Python, this transpiles to this Python program. So you see suddenly we have quite a more complicated project. And you can now see that I made this as a project with a project file. So I'm referencing other NuGets and referencing Fable core. I'm referencing this async RX library that I made a long time ago. So I can pull this Fsharp library, and it's a special Fable library, so it includes the source code. So when I compile it, it will compile the source code to Python. If you took that library and took it to a Fable JavaScript project, it will transpile it to JavaScript. So this async RX project now runs on both .NET, Python, and JavaScript. Same code. So we can say here Fable minus and now it compiles all the code to Python, and we can run it. And now you have this character stream that is being, it might be a bit small for but it's quite interesting to see that you can have, when we take the async RX library, then we would have like combine.fs, which is sort of super complicated Fsharp code dealing with this stream processing. And it has uses mailboxes instead of locks for synchronization, which means that as long as Python implements mailbox, then we don't need special locking in Python. So that's why this library works fine for all the different targets. So if you look at the Python version of this one, we should probably save it. Okay, yes. So you see the code is fully typed, but it really doesn't help to read. So you still, but this is sort of fine, because now you can make a contained library that works on Python. You could publish this as a Python library. You could use it from Python. And you can get it fully typed without having to learn about how you declare generic types in Python and all of that. So it's quite fun when you work on a project like this and you transpile it, and you suddenly sort of get into this critical mass where you see that you can sort of compile anything. And you just throws Fsharp code at it, and it chews it and spits out Python code, no matter what you put. So now it's sort of only this strange, sort of the BCL is super huge, the class library in .NET. So it would be a impossible task to implement it all. But you usually don't have to use all of it, and sometimes if you're missing a function, then it's not that hard to add it, actually. Let's see, let's go back. So that was the Timeflies demo. And you could see that we have support for dependency management. We use NuGet. So we distribute the Fable packages as NuGet packages. We include the source in them. we can probably see here if we wanted to. If we go to the, this is the project file for async RX. So it lists all the file we need, and then it just has one line down here where it says, in addition to this, we can add a PyProject TOML, so we can say if this project has some Python dependencies, which is do not have, and we copy the project file and all the Fsharp sources into the NuGet file package. So that is all we have to do in an Fsharp project to make it Fable compatible, and sort of also have to be careful with the dependencies. This project cannot depend on sort of any Fsharp assembly. It can depend on other Fable packages, but not normal .NET packages. So for Python we use poetry, and in Fable Python we still use poetry. And then SciPy, a famous Fsharp developer, have made a tool called Femto, which helps you keep these dependencies in sync. So if you have a huge project with a lot of NuGet dependencies, and these NuGet dependencies have Python dependencies, then this Femto tool will help you to check if you have installed all your Python dependencies as well, and if they are in sync. So this was sort of the status a few months ago. It's sort of cool, but what should I do with it? Can we actually do something useful? Will it sort of be this Timeflies demo? It's sort of cool to look at, but will there be anything else? So the thought was sort of, could we build a real Fsharp application that runs on Python? Is that possible? So started looking at Fable Giraffe. So we have heard in other talks that if you want to start with Fsharp, you should use a Giraffe web server. And Giraffe is this sort of beast that runs on top of ASP.NET, which runs on top of Kestrel, this magnificent, super fast web server core, or what we should call it. So how would we do that for Python? It actually turns out that Python has the same kind of layer. In Fsharp we have Giraffe, we run on top of ASP, that runs on top of Kestrel. In Python we run everything on Fast API, that runs on top of Uvicorn, which is, no, it runs on top of Starlet, which runs on top of Uvicorn, which runs on top of which is an ASGI server. So that means that if we could make our Giraffe ASGI compatible, then we will sort of get all of this for free. So let's look at that project. Fable Giraffe. So what I did, I basically took all of the Giraffe code. So you have the exact same way of declaring stuff. You have this super complicated compose function that is exposed at this Kleisli composition. And I'm basically just taking the code and doing exact same thing. This is the same code that Giraffe has. So what did we have to do differently? The thing is that ASP has an HTTP context, and this context has the request and response object. So I had to sort of re-implement that one. So I'm making an HTTP context. It has a request response. And for the response, I can write asynchronously. Here's a request. Oh, sorry. So this basically re-implements what I need in the HTTP context. And the good thing with this is that I give it what's called the scope and the receive and the send, and these are from ASGI. So that means that I can say that I can have a definition of what an ASGI app is, which is what all Python web frameworks use today. And it means that if I'm ASGI compatible, then I can plug Giraffe into any other. I can say I want to use fast API, but I want the routing from Giraffe, which is sort of insane. Or I could say that I want to run Giraffe, but I want a static file handling from Starlet. So now I can suddenly compose my web application and take all the nice features that exist in Python from before. And I can even say that now we have this component that I can give back to Python community, and you can actually use it. But then I sort of had to write Python bindings or something because yeah. So that means that I can now say that I want to have an application. We can look at an application here. So I can declare an application which has a web app. I can make routes where I can ping it or even do some logging. So I've added a log handler. So I added an extension method to the host builder that you have never seen before. So I'm sort of mimicking that this is an ASP.NET host builder. But what it produces is not a host, it is actually an ASGI app. So this app is Python compatible. And I say now I'm using structlog, which is the most used logging framework in Python. And I can actually stitch in static file handling from Starlet, which is one of the fastest web frameworks in Python. So we can try to run this. So I've made a little helper script using fake. Fake is an Fsharp make clone. So now it actually runs. So you see that we have the last thing we did was to say that we do poetry, run uvicorn, and the input is program.app. So now we are saying to uvicorn, this Python framework, that you should look at Fable Giraffe, there we are. And we are at this program. So we say to it, look at program.app, and it's this object. So if we look in the build here where it got built, then we have the program.py. So this is now the Python code for the application. And way down here we should have we have the web app. So these are the Giraffe web handlers. And now we have app, which is an ASGI app, which is a callable that takes this scope object and then this receive and send function. So it's an asynchronous function that takes two asynchronous functions as input in addition to this scope. And now we build this ASGI app. Let's see if we. So that means that we can look at this and let's see. Here should run at port 8080. Yeah, we can call this ping. Oh, 80s, thank you. And we get pong back. So now we see that we have, and now we see the log output of structlog. So you see that the Giraffe middleware, Giraffe returned, in Fsharp it will say some or none, which I think is not informative. So I've changed it to be the actual status code. And we got a 404 because we don't have a fav icon yet. And we have the, so this is sort of a combined, for the human readable form, we see it as a nice log output. In production, this will be just a JSON object. And we could call the JSON endpoint that we get. So we are sort of gotten quite far, but not sort of far enough. So that's why I started to look at what would it take to sort of implement this remoting API, because that is sort of the secret sauce of safestack. You have this front-end application that where you can define your API this way, declaratively, and you have an implementation of that API on the server side, and then the client has a proxy of it, which generates HTTP request. So then you have your shared model, you have your shared API between the client and server. So I thought, could I sort of re-implement Fable remoting? So it was not that much code actually. Took like 150 code lines. Written in Fsharp. And then I just transpiled that to Python, and I can use remoting in. So let's see how that works. We can go to the demo Python. So this is the sort of basic safestack demo. If you use the safestack template, you will get these files here. We can look at them here. And if we look at, so this is the back end of safestack. You have the storage module here with the to-dos. They are so just, you're not using a real database here. So we have just an array, resize array, or a list to hold the to-do list. But then it has this to-do API, where it implements this to-do API. And that to-do API is defined in this shared code that is shared between the client and the server. So this is the remoting API for safestack, for the demo. And the server needs to implement this one. So we do that. We use our sort of fake web host builder that returns an ASGI app. We can put on logging and add our web application that is mounted on Dash API. So now the client app will so this is the Fsharp version of the client app that will render as a React app, and then every time you need to deal with these to-do items, you call over to the server side. So try to start that, and now we have two Fable processes running. One is compiling the server to Python, the other one is compiling the client to JavaScript. That looks like the server side. And now it's going through the front end. This is not something that would happen in production, because then it's all pre-compiled. You just deploy it. But for the demo, now we are building it, so that's why things takes a bit of time. And you see, especially with JavaScript, there's a lot of stuff happening, and you have this Webpack development server and all of that stuff that... let's see if this one actually started now. So there should something be running on port 8080. Let's see. And we have safestack running on Python. So now to test this, I can say Python rocks and add that item. Let's check the log, and we can see that we first we got a get for the to-do items, get to-dos, and now we had a post to -API add to-do. So now we know it works. And to sort of prove it, we have to do a refresh. And then we see that we still have the state we added. So the server is still running, it has the state, we can connect with the client, and so that means that if we added that static file handler to our to this demo, then we could actually do a .NET package on it and deploy it to Azure if we wanted to, and it would run Python. And then why did you want to do that if it's sort of 10 times slower? Yeah, but now I can use my favorite data science library in the backend, which I couldn't do before. So yeah, we have looked at safestack. And we have some bindings here. I will show it just super quick how we can use these bindings for, let me see, quick test. So this was something Alfonso made a few days ago. Like that. And bindings have been quite hard to make in so let's say we had a program. We want to take A and B and say, now we can say that this is, and we need to add one library here, open core, like that. Do a triple quoted string on it, and like that. Now I can say A plus B. Well, Copilot is a bit... and we can even say that we want this to be like that, and do... So now we suddenly have a function which is, this is an Fsharp program, but everything inside here is suddenly Python. And I can hover over this, or like, at least I could do it earlier today. But you see that we have full syntax. We can say match a... Copilot wants us to write this, so it looks good. So now we suddenly have this sort of fused or combined world of Python and Fsharp. So if you want to do, writing these Fable bindings has been quite sort of a black magic or dark corner of Fable for a long time. But now we suddenly, you can say that, okay, let's make an Fsharp here, and let's make an Fsharp function, and inside of that, I can do my Python, which I know how to do. I don't need all this crazy stuff. So this is just in the beginning. It will be really interesting to see how that goes. We need to round off here, so let's go back to them. So yeah, is this .NET? My take on it, if it walks like a duck and quacks like a duck, it's a duck. And this, if it smells like .NET, for me it's still .NET. So that's not a problem. Yeah. Let's go to, so the takeaway from this talk is really that Fable is awesome, and learning F# will make you a better C# programmer. It did make me a much better Python programmer. And if you want to learn more about Fable, go to these links, fable.io. There's a REPL there, online REPL. You can try all the languages, write some code. And below you will find a link to Fable Python and some instructions on how to get started there. So with that, I will say thank you to all of you. Thanks for coming.